Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get
Most
into
car
it.
owners have a vague idea of what the octane number is. As a rule, their knowledge is limited to the understanding that the higher this indicator, the higher the quality of gasoline. Alas, but this interpretation is far from the truth. And since novice drivers are taught a lot of things, but the octane number is not included in the training course, a bit of information on this topic will not hurt anyone. What octane number means? Under this obscure term, understand the degree of resistance of fuel in liquid form to detonation. In other words, what is the threshold of ignition of gasoline under the influence of pressure, that is, under compression? A mixture of two hydrocarbons, iso-octane and N-heptane, is taken as a reference. However, the methods of determining the PM can differ, so there is a classification of this indicator depending on the method of determination. VLF, research VLF, HFO, motor HFO. Since the instrumental mechanisms of these methods are not the same, there is a difference between the BSI and BSF values, which is called the sensitivity of liquid propellant. Both methods are laboratory methods. And if we are talking about a real indicator obtained on a working power unit, we speak about the actual octane number. It is determined with the help of a special bench on a running engine. But the closest indicator to reality is the road octane rating, which is measured on a moving vehicle. Iso-octane is a substance that is practically unflammable under compression force, so a mixture consisting of it alone has a maximum possible octane rating of 100. On the contrary, a mixture consisting only of N-heptane has 0 octane number. At the same time, combustion of N-heptane as a result of exposure to even minimal pressure is accompanied by characteristic NOx in the CPG, which are called detonation NOx. They occur if fuel with an unsuitable octane number for this power unit is used. Metallic ringing is formed as a result of the propagation of sound waves that appear as a result of too rapid combustion of fuel assemblies. By repeatedly reflecting off the surface of the pistons/cylinders, they become audible and recognizable to experienced drivers. Thus, the octane rating indicates how fast the combustion process takes place in the engine cylinders. Influence of the octane rating on the performance of the powertrain. The relationship between gasoline combustion rate and OC has a linear form. The lower the octane number, the less time is required to ignite the fuel assembly, which directly affects fuel consumption. If it burns faster than it should, it enters the combustion chamber at a correspondingly higher rate. But it doesn't mean that by simply increasing the efficiency, we can save money. If combustion is slower than it should be, it is also bad, because the efficiency of the engine decreases, which leads to a loss of engine responsiveness and deterioration of dynamic characteristics. Pouring into the engine, running on 95 gasoline, the fuel with an OHF equal to 92, you will get an increase in consumption. If the situation is the opposite, instead of working 92, we pour 95, the consumption will remain the same, and the engine power will decrease. So, it is possible to use unsuitable gasoline, but it is undesirable. It is recommended to do this only under force majeure circumstances, but not on a regular basis. How to determine the octane number of gasoline? The octane number, according to GOSD 511/82, is measured using a special unit UIT 65M, consisting of the following components: a detonation measuring device, a single-cylinder engine characterized by a dynamic compression ratio and equipped with a detonation level sensor. Devices designed to regulate the probability of occurrence of detonation processes. The measurement algorithm itself is as follows. The tested fuel is poured into the engine and, by manipulating the compression ratio, the occurrence of detonation phenomena of a specific value is achieved. A reference mixture characterized by the same magnitude of detonation is made, and by the ratio of N-heptane to iso-octane the BF of the initial fuel is determined. GOSD 8226/82 describes the procedure of PM measurement by the research method. In this case, the mode of operation of the motor is characterized by lower loads, as a result of which octane rating is always obtained at parse slightly higher than the PM. If it is necessary to measure the octane number independently, it can be done with the help of devices that are freely available. As an example, an octanometer, which uses a measurement method based on the dielectric permeability of liquid fuel, this value changes in proportion to the octane number. Read also, proper storage of gasoline in the house. The peculiarity of the method lies in the preparation of a calibration scale, which allows to determine the RH with acceptable accuracy. To construct such a scale, a quantity of N-heptane and gasoline with an accurately determined octane number will be required. A similar procedure can be used to determine the cetane number for diesel fuel. The feasibility of this method is based on the fact that gasoline is currently made without using the direct distillation method, but rather through the technique of compotting or blending of components. However, the determination of the octane number of gasoline by this method has disadvantages. It is necessary to have already identified fuel to perform the research. The influence of external factors can strongly distort the measurement results. The method is not suitable for measuring gasoline of different types and produced by different methods. Each instrument must be calibrated using reference devices. Measurements must be carried out with careful observance of the temperature regime given in the device specification. All instruments measuring the octane rating use a similar measurement principle, and therefore their advantages and disadvantages are generally identical. Note that the octane number can be higher than 100 due to the inclusion of certain additives in gasoline, but none of these instruments is able to work with such liquids. One of the most affordable octanometers is the domestically developed Octus, which can be purchased for about 3,500 rubles. The German Digatron device is more accurate and reliable, but it costs several times more, about 600 euros. Nevertheless, it is the most popular on the Russian market. Its work requires a reference fuel, which is compared with the fuel under study, and on this basis conclusions are drawn about the octane number of the latter. The disadvantage of this octanometer, as well as other analogs, is that each measured gasoline from different manufacturers will require a corresponding reference sample, because in this case the calibration relationship between the octane number and dielectric constant will be different. In addition, each measurement must be accompanied by calibration procedures, which also affects the accuracy of the measurements and the reliability of the results obtained. A rather expensive but effective device of Russian manufacture is the octanometer Octan-IM, 45 to 50,000 rubles. Among its features is the presence of a built-in memory that allows you to store up to 10 calibrations. The accuracy of the device does not cause any complaints. The PE 7300M device falls into the same price category, and its feature is proprietary software that allows you to interface with a computer/laptop. The octanometer is able to take into account the temperature factor, which increases the accuracy of measurements. Dielectric constant has a weak dependence on ambient temperature. The Shattuck's SX 100M device, which costs about $1,800, has approximately the same functionality. It is equipped with a temperature sensor and therefore measures this parameter more accurately than PE 7300, which does it purely by software. Whether you are measuring the octane rating of 92 or 95 gasoline, if you have a reference fuel sample, the results should match the required accuracy, but within the same batch of gasoline. Other supplies, even from the same manufacturer, may require additional calibration of the instrument. Compression ratio and GFR. All possible varieties of gasoline are characterized by a very specific compression ratio, which is regulated by GOSD. Familiarize yourself with the correspondence of the octane number to the compression ratio in the following table. Read also, ethylated and unleaded gasoline. Looking for the difference and find out the main characteristics. Gasoline name which state, standard compression ratio BSI BSF 7272 208 4777.00 76 76 200 and 8,477 7.50 80 80 76 511 059 78.0 91 91 82.5 FIS 511 059 79.00 AI 92 92 83 238 00 1168 97.9.20 AI 9393 85 200 and 8477.9.30 AI 9595 85 FIS 511 05979.50 AI 9696 85 238 /979.60 AI 9898 87 FUS 511 059 710.00 Methods of lowering the WP. At present, gasoline of 7680 grades can no longer be found in the network of domestic gas stations. However, machinery designed for these types of gasoline is still available and, as we noted above, it cannot work on gasoline with a higher octane number. So the need for low-octane gasoline remains at a fairly stable, albeit relatively low level. There is a way out of this situation: artificial reduction of the octane number of gasoline to the required values. At home it is also possible to do this, but rather roughly. If you, for example, have a motorized machine released more than 10 years ago, you will need to lower the octane number from 95 to 80. The easiest way is to simply open a container of gasoline. When interacting with air, the daily RH will decrease by about 0.5 units, so the procedure will take about a month. The obvious disadvantages of this method are duration. The second, more common method, can be called dilution of gasoline with kerosene. And although it is considered the most common in relation to cars running on low-octane gasoline, its main disadvantage is the difficulty of selecting the required proportion. That is, the accuracy of the method is very low. However, the same can be said about the first method. So in any case, you will need to measure the octane rating using an octanometer. How to increase the octane rating of gasoline? There are also opposite situations when only 92 gasoline is available at the gas station, but 95/98 is required. In this case, you can try to raise the octane number of gasoline yourself, for which purpose a special substance is added to the fuel, generally referred to as an antidetonator. Let's consider all the main additives used as an antidetonator. Ordinary ethyl, methyl, alcohol may well raise the OH by the required amount. Adding a liter of alcohol to 10 liters of 92 gasoline, you can get fuel with an Na equal to 95. Such a mixture, by the way, will be characterized by a less toxic composition of the exhaust, but this method has disadvantages. One of them is considered to be an increase in the vapor pressure of the fuel mixture, which leads to an increase in the probability of formation of plugs in the fuel line of the car's power system. The second disadvantage of the alcohol mixture is an increase in hygroscopicity, which precludes the possibility of storing fuel for any length of time in the open because of the possibility of accumulation of a critical mass of water in gasoline. Tetraethyl lead has physical characteristics that make it one of the most effective anti-detonators. It is both highly viscous and has a very high boiling point, about 2000 degrees Celsius. It was first used as an additive to increase the OHF almost a century ago, in 1921. It allows to increase OHF by 15 to 17 units. It is this substance is most often used to increase the octane number of gasoline with their own hands. Unfortunately, and tetraethyl lead has disadvantages that limit its use. This is the formation of lead oxide during the combustion of diluted fuel. This substance forms a precipitate that settles on the inner surfaces of pistons, valves, and other components of the CPG. To minimize the formation of such fouling, in tetraethyl lead added special substances, diromethane, bromoethyl, dibrompropane, which bind combustion products of lead, contributing to their removal to the outside through the exhaust tract. In conclusion, understanding octane number and the various methods to modify it is essential for optimizing engine performance and efficiency. By utilizing techniques such as blending fuels, adding octane boosters, or employing advanced refining processes, we can enhance fuel quality to meet the demands of modern engines. As we continue to innovate in fuel technology, the importance of octane number will remain a key factor in driving progress in the automotive industry. Thank you for watching, and we hope you gained valuable insights into this crucial aspect of fuel science.